All right, so let's go ahead and review what a composition function is. So you'll see that in this case, the first thing we're going to do is we are going to transform this line, essentially is what it is. And the second thing we're going to do is reflect it across the x-axis. So given line segment with endpoints, -2, 5, and 6, 0, find the points after completing this composition of transformation. Remember to do the second thing first. Okay, so t of 3, 4, well that means I'm going to do x plus 3, y plus 4 to each of these points. So my original point is at -2, 5, and I know you don't have graph paper, so I'm just going to quickly graph this here, and A, so is a line segment that we're transforming. So I'm going to move it essentially 3 to the right and then up 4. And so basically I'm just going to take my coordinate m, which is at -2, 5, add 3 and add 4. So m prime would be at 1, 9. And then I do the same thing to a. So a is at 6, 0. Oops. And I'm going to add 3 and add 4. And so a prime would now be at 9, 4. Now for the second thing, it says a reflection across the x-axis. Well, I know for that x is going to stay the same and y is going to change. So m double prime would be at 1, -9, and a double prime would be at 9, -4. And then when I graph that, I will notice that this moved up and over, and then it reflected down. So it should be somewhere in this quadrant down here. All right, today we're going to add the fourth transformation, and that is a dilation. So here you'll see Queen Bee. Her picture has been dilated 3 times. And if you look, a picture is a very good example of a dilation. Let's go ahead and see if this video is working on BrainPop. And it is not. So essentially, anytime you take a picture or make a copy of a picture, you blow something up, that is a dilation. Televisions are dilators. Your eyes dilate when you go to, when you turn the light on, your pupils get really small, and then when you turn the light off, they get really big. Right. So, so far we've learned about reflections, rotations, and translations. Those all keep the integrity of the shape. So the size and the size stays the same, so you have congruent figures. With a dilation, we're going to start talking about similar figures. So we're going to take it back a little bit. All right. So a dilation is a transformation in which the size of a figure is changed. The image is similar to the pre-image found in the dilation. So you can blow the figure up or you can make it smaller. So if you're going to blow a figure up, when x is greater than 0, when x is greater than 1, your shape blows up, it gets bigger. When x is less than 1, then it gets smaller. But x is always going to be greater than 0. All right, so let's take a look at some examples here. So it says, first, you might want to try to solve these on your own and then come back to it. So basically what you do is you take your scale factor, and sometimes we call it k. So if I said that k was greater than 1, it would make the figure larger. And this is going to be multiplication. So it's a little different than a transformation where you add or subtract to the coordinates. Now you're going to be multiplying. So basically, if we use the rule 4x, 4y, we're essentially making our shape 4 times bigger. So all you do is multiply your x and your y by 4. So a prime would now be at -16. Find the coordinates of A under D4. This is another way. So One way we'll write the rule is 4x, 4y. Another way we can write the rule is simply by writing d4, d for dilation of 4, because both coordinates are going to be multiplied by the same thing. If you don't multiply both coordinates by the same number, you end up with an image that looks either too wide or too tall. So you would get the same answer of -16, 8. And then here again, it's the same situation as the one before. So a dilation can either enlarge or shrink a shape. And so what we say about the k of the scale factor is what I just told you. If k is greater than 1, then we call it an enlargement. So that means you're taking a small shape and making it larger. Okay? If k is between 0 and 1, then it's a reduction. So if k is greater than 1, you're going this way. If k is between 0 and 1, you're going this way. So essentially what we mean here is a fraction or decimal. Okay, so k is a fraction or decimal, you shrink it. And essentially what you're doing is you're kind of you're starting at 0, 0, and you're extending your shape out. So let's look at some examples of what we do here. I think my computer really wants to work today, but it is what it is. All right, so here would be a composition review using dilation. So the first thing we're going to do is dilate by 1/2 Kyle over here. All right, so if I do that, I'm multiplying each coordinate by 1/2. So k, this would be times 0.5 or 1/2. So half of 2 is 1. Half of -4 is -2. Y would now be at -2, -2. L, -2, 3. And E, 1, 3. Again, I just multiplied all the coordinates by 1/2. Next, I'm going to do an reflection across the x-axis. So I got to remember that rule. If you're going across the x stays the same, the y changes. So my next k double prime would be at 1, 2. Y double prime would be at -2, 2. L double prime, -2, -3, because the y is changing. And then E double prime would be at 1, -3. So let's go ahead and graph our original shape, which is at here 2, -4. My thing's not, I'm not going to be able to graph it because somehow my board is not working well today. But anyway, these are the new coordinates. And what you should notice is that the shape would start out big, and it would probably be like in the middle here. Then it's going to shrink down, and then it's going to reflect up. So it would have been somewhere around here, then it's shrinking down, and then it's flipping across the x-axis. And this is page 16 in your packet if you wanted to graph it yourself. All right. Here's a second example. This is also on page 16 in your packet. And this we're going to find the coordinates of the image of a right triangle, Ha. All right. So the first thing we're going to do is a dilation of 2. So essentially what that means is I'm taking all my coordinates and multiplying them by 2. So H prime, and I'll just write D2 here so you know what I'm doing, would now be at 0, -2. O would be at 6, -2. And P would be at 6, 4. And again, you can graph this on your graph paper. For whatever reason, my pen's not working today properly. And then we're going to do a rotation of 90 degrees. And so what that means is I'm going to take my coordinates and flip-flop them. So y comes first and then x. And the x is going to change and go negative. If you do that, y comma negative All right, so my new h would be at -2, 0. O double prime is at -2, -6. Flip-flop, change the x. P double prime is at 4, -6. All right, so what's essentially happening is that my shape is somewhere over here. Okay, it's like right triangle somewhere over here. And then what's going to happen is it's going to get larger. And then it's going to rotate 90 degrees clockwise. So it's going to end up over here somewhere. And again, that's just a rough sketch. I'm not graphing because my pen is currently not working correctly. All right. So what you're going to work on now is on page 15. There are 9 problems for you to solve. Go ahead and work through these 9 problems. You may work with a partner if you'd like. And there's also a Desmos activity. And if you would like any extra practice for the test, it's on, which is on Friday. You can go to iExcel and log in. So there is a Desmos for dilations. There's the information. And make sure you get your practice problems done. We'll go over the answers in class or tomorrow.